Hello, my name is Julian Arrieta, and this is my presentation for the LSAMP SRA 2023 conference. As public and private organizations launch new and innovative spacecraft, our current satellite tracking systems are put under a greater load than ever before. More satellites enter the atmosphere, making our systems less and less accurate. The field of view partitioned, generalized labeled multi-Bernoulli filter, or the filter for short, is a new method for tracking satellites that is able to track satellites using less resources. However, the filter's capabilities have only been tested while tracking one type of orbit. This experiment aims to measure how well the filter performs while tracking satellites in different kinds of orbits. To do this, we run a simulation of satellite spaceflights over 36 hours and track each satellite using the filter. Then, we compare the satellite's actual position in the simulation to the filter's estimated position. A representative population of 25 satellites was designed in order to describe to the simulation what a satellite orbit should look like. Each test group was created by making small changes to the representative population's orbits. The first test group consisted of 1,000 satellites orbiting Earth. This population was used to represent how well the filter performs while tracking most types of satellites. The second test group was made up of 500 pairs of satellites. These pairs had very similar orbits to each other. Satellites behave this way when making repairs or while preparing to dock. The third test group was made up of several clusters of satellites 3 to 8 size large, totaling to 1,000 satellites in orbit. Research satellites behave this way while collecting data from specific atmospheric regions. After testing each group, our data suggests the filter is able to track individual and pairs of satellites with high efficiency, reaching almost a 0-kilometer error within 8 simulated hours, and with pairs of satellites only taking slightly longer to process than the baseline. However, the filter was unable to track the cluster population with the system resources available. The next steps are to decrease computer load during simulation enough to complete tracking of the cluster group. Overall, the filter shows promise as a tool for keeping low Earth orbit space missions safe and sustaining our ability to track satellites for the future. Thank you very much for listening to my presentation.